Good evening, ladies and gentlemen. I'm David Wallace. I'm Treasurer at the Royal Society, and I'm really pleased tonight to be able to welcome you to the Society on behalf of both the Royal Society and the Royal Academy of Engineering. As those of you who are new to the Society may not know, the Royal Society is our National Academy of Sciences. So tonight we're going to be discussing a report which is a joint report of our National Academy of Sciences and our National Academy of Engineering. Now, I have one piece of business, maybe two perhaps, which I have to announce. The first is that would everyone now please check that your mobile phone is switched off? And that includes the panel. And I think, although it's not in my brief, I should say that to my knowledge, there are no fire alarm tests scheduled for tonight. So if one goes off, follow me because I'll be leaving. But it's a bit like the airline pilot and the airline hostess thing, Stuart. You know where to go. Let me now turn to just a few words of introduction to Nick Ross. It's the conventional thing, Nick, of course, that you need no introduction, but I've got a little brief here, if I may. Of course, Nick is one of our best-known factual broadcasters. He's fronted Crime Watch, I'm sure we all know that, since its inception 20 years ago.
I was a child when it started.
Yes, we'll come to that. And has presented a wide sweep of the BBC's journalism and news, including rolling news, current affairs, politics, law, crime, and consumer issues, a very wide range. And Nick chairs the Jill Dando Institute of Crime Science at UCL, and he's president and patron of several charities, including the Apex Trust, which is helping ex-offenders find work, as well as a member of a number of advisory boards of crime concern and victim support. His interest in science is, especially bioethics, is a long-standing one, and I can personally vouch for this, because actually, although I think I had to remind Nick, given all the water that will have flowed under his bridge, that he facilitated a discussion on neural networks which I participated in, and I suspect that that was close to 20 years ago. And the only thing that still surprises me, if you look at me and you look at him, he hasn't changed. So I think without more ado, Nick, we're absolutely delighted that you're here to facilitate this evening. Thank you very much. Over to you.
David, thank you very much indeed. And thank you for coming. I must say we feel very grand sitting up here on the stage. But I'm very conscious there's a great deal of expertise also in the body of the room here. And we'll try and run this as informally as we can. I hope there's going to be a great deal of dialogue. What tends to happen at meetings like this, of course, is that people are a little bit diffident at the beginning in putting their hands up. And then it's very difficult at the end because I can see a forest and people are very frustrated. So come in right from the start. Now, just as David gave some introductions to me, let me give some introductions to nanotechnology. I first came across the term when I was chairing the jury of the Rowan Poulenc Science Book Prize, now called the Aventis Science Book Prize. And it's a pretty onerous thing. You get something like 200 books, and there's no way you're going to read 200 books. The very first one I picked up was called Nanotechnology. And as befits the subject, it was quite a slim volume. It's quite a small book, but it was a very, very good and really interesting book. And I knew nothing about the science of it. And all my fellow jurors, most of whom were scientists, I'm not by background, all said it's rubbish. I mean, it's so way out beyond the horizon, won't even consider it, won't even put it in the short list. And I battled away because I thought it was very, very interesting. But I lost. And I heard nothing more about it, really, as I suppose most members of the public heard nothing more about it until we heard the Prince of Wales banging on about it. And we read the quotes. I think it was the Independent on Sunday, was it, about, we're all going to turn into a universe of grey goo. There is a description of an optimist. I don't know if you know the definition. An optimist is someone who thinks that we live in the best of all possible worlds. And a pessimist is someone who fears that is indeed the case. And it always struck me that Prince Charles has an ability to be the eternal curmudgeon about modern life. But in this time, in this occasion, of course, he didn't actually say grey goo at all. Those words were almost put into his mouth by the press. I think that term originally was the subject of a book by Michael Crichton. It turns out, in fact, that the Prince of Wales was never even against nanotechnology, which is quite interesting, like so many other things, an invention of the media. But it was quite important, that episode, because it did flag up that this could be a hugely controversial issue. And I think it's to the great credit of the Royal Academy of Engineering and the Royal Society that they have got to grips with this relatively early, I mean, before this becomes a huge and divisive controversy. The only other thing I really want to say is that nanotechnology could well turn out to be, well, certainly one of the most important technologies since the invention of the computer. Possibly even more, possibly more than unraveling the genetic code. It's very hard to tell. It's a long, long way out, and life has an ability to turn out like you didn't expect it to. But it could be that after the agricultural revolution, the industrial revolution, the information revolution, perhaps we'll have the tiny revolution. I don't know. But as with all previous transformations, there's no doubt it can do harm as well as good. There's no doubt it can advance very rapidly where we thought it wouldn't advance at all. There's no doubt that it can suddenly stop and die and get stuck where, in the very places we expected miracles. And there's no doubt that the way it will interact in other things in our knowledge and in the world around us, the universe around us, will make it relatively unpredictable in its consequences, however hard we try to look ahead. Could I just ask, before we go on, how many people here have a pretty good grasp of what nanotechnology is? Oh, actually, that means quite a lot. It's relatively new to. And how many people here would say they'd struggle to define what nanotechnology is, really? Look, in layman's terms, and I can tell you this quite well, having read the report, very, very briefly, it's about making almost unimaginably small materials and devices. It's when you get down to the atomic level, something like the grain of sand almost becomes, as big as a planet, or by the moon by comparison. And when you're working with at this nano scale, things turn out quite differently to the sort of life that, as we expect things when we're at this sort of scale, as people who are 5 to 6, 7 foot high, whatever. Tiny things have more surface area for a start, which means a lot of things. It can mean that they're much more reactive, for example. And it means that they're prone to unexpected effects, quantum effects. So you can do quite different things with these tiny particles. And in the very long term, the supposition was, and that book that I first read all those years ago, promised that we'd be making tiny little robots. I remember one of the phrases, I'm afraid not as eloquently as the author had written it, I can't even remember the author's name, but he, and I think it was a he, said that even our finest engineering now, we're taking trillions and trillions of atoms and bashing them. And that's regarded as very, very fine precision engineering. But what about starting at the other end and building a machine atom by atom up, more or less in the way that in biology, the genes can produce individual proteins or enzymes. That's the idea. That's probably a bit of science fiction. That's what the report suggests. More immediately, we can make new paints, new lubricants, new fuels, perhaps new semiconductors, the electronic switches that make computers work, maybe new medicines that target specific areas of the body. And that produces a whole bunch of risks. And those risks are things like what happens if we breathe in nanoparticles. Indeed, I'm not sure whether nanoparticles can come, if they're that small, can they get through the skin? What are the barriers to them? What effect will they have on wildlife, on the soil, on the weather, on the climate? And who's going to control them? Who's going to benefit from this? Who's going to lose out? Well, that's what the Working Party's been looking at. As I say, it's been doing so way ahead of the curve, which is really very satisfying. And I suspect the report is going to be very influential. The Americans are way behind on this one and will certainly be looking to this, I would have thought, as a blueprint, as will all policymakers. The government chief scientist, Professor David King's in the audience. There are a lot of other significant policymakers here. And this is going out by web broadcast. And incidentally, that means that if you are speaking, it's quite important you speak really clearly into the microphone, please, so you can be heard by people who aren't necessarily in the room. Now, let me introduce the panellists. It's been chosen so that 2 are members of the working group which produced the thing, and 2 are not. On my right, as you look to me, on my left, is Ann Dowling, who chaired the Working Party. I don't know, have you got little CVs on the seats. If you haven't, let me just say, Professor of Mechanical Engineering at the University of Cambridge, a Fellow of both the Royal Society and of the Royal Academy of Engineering. But I don't think Anne works directly with nanotechnology or ever has done, so was able to come to this with a fairly open mind. Deidre Hutton, on my right, or the left as you look at the stage, Chairman of the National Consumers Council, also a member of the Better Regulation Task Force and Deputy Chairman of the Board of the FSA, the Financial Services Authority, bringing a really important perspective to this, which is not the people who plan to make this, but the people at the end of the chain, the public, the consumers in this. There's Doug Parr over here, who many of you will know is Chief Scientist at Greenpeace, who came to them, I think, from Friends of the Earth, and has a PhD in, I forget what it is.
Atmospheric chemistry.
Atmospheric chemistry, well, quite useful for this. Ian Pearson, I hate Ian because he knows everything about everything. He's a futurologist who works for BT. It's easy to predict anything except the future. His job is to do that, is to keep BT ahead of events. Now, and I just wonder, before we really get going, for those who haven't read the report, and it's a pretty dense, though very well written piece of writing, but I haven't even had a chance to get through. It's only 10 pages of the summary. Just tell us briefly what your main recommendations are.
Yes, but actually, Nick, before I do that, can I just say that nanotechnology is wider than just nanoparticles, in case your introduction gave that impression. So nanotechnology means working at the scale of a millionth of a millimetre, so very, very small scales. And yes, sometimes those might be particles which have surface area like that, but equally it could be making computer chips with that sort of resolution. And actually we've been doing that for over a decade. Or it could be DVD readers or CD readers, and again they work at these very small scales. So there's a whole spread of technologies that come under this, and we shouldn't give people the impression that it's just particles, because that's only a very small subset of a very wide area.
And indeed, one of the most famous early experiments was at IBM, wasn't it, where two
Yes.
of the workers there used nanotechnology to create, in a millionth of a millimetre, what it was, the letters IBM.
That's right.
Yeah.
So coming on to our recommendations, one of our, not really a recommendation, but one of our comments is actually we should stop saying nanotechnology, because there is this huge spread of very different technologies. It's actually better to refer to it in the plural as nanotechnologies, because anything we say that applies usually to only part of it, and there we need to make that distinction. So mostly we really see, as many other people do as well, the huge potential that nanotechnologies can bring. Part of our remit was to say whether there are any health or environmental issues associated with nanotechnology. And we are concerned about nanoparticles if they're in a form where they're free to interact with people or the environment. So what I mean by free is sometimes nanoparticles would be used in a form in which they were fixed. So one example of that is self-cleaning windows. Self-cleaning windows have a film on them which contains nanoparticles, but they work because the nanoparticles stay fixed perfectly safely.
And you're using the present tense because that's already in production.
Yeah,
It's already on the market.
That's on the market. Other applications involve nanoparticles in a form which they're free to move around, or perhaps in skin preparations. And there we have concerns. We're concerned because when particles, as you said, are very small, they have more surface area and they have different properties. And because they have different properties, that's hugely exciting. That's why people want to use them. But also, they may have different toxicity. And that there are some examples where in the nanoparticulate form, a chemical has more toxicity than the same chemical in larger form. And that leads us into one of our main recommendations, which is that nanoparticles should be treated as new chemicals when it comes to regulation and to labelling.
In other words, they should be treated as though they are hazardous materials until...
Not necessarily hazardous. What we're really saying is you can't extrapolate just because you know the properties of a chemical when all the particles are in it in a large standard form. It's not clear. You don't know that in nanoparticulate form the same chemical will have the same properties. So just treat it differently. It needs new testing. It needs to be tested and treated just as a new chemical when it comes to regulations. And because of that, we would like to restrict exposure of humans and the environment to nanoparticles in this free form and to nanotubes until they're better understood.
Just tell us what a nanotube is, because that comes up a lot in the report.
Yeah, so a nanotube is basically a long, thin nanostructure. They have exciting properties. They may conduct in ways that can be designed in. They can transport water. They have very small diameters and longer lengths, so they're small fibres. And one of the health concerns there is other small fibres like asbestos we know cause problems when they're inhaled. And nanotubes have some similarity to that. So going back to our recommendations, when nanoparticles are used in ingredients, for example in cosmetics, we would like them approved by an independent scientific advisory body before they're declared safe for use. And we'd like the regulators to take account of potential novel features of nanoparticles in regulations.
Right. Now, I haven't asked people on the panel to come with prepared statements because I want to leave as much as possible for the floor. But I am going to ask each of them just for their first reactions to the report. Well, actually, Deidre, it's not your first reaction. You helped write the thing. Is there anything you'd like to say to bring out?
Yes, I think there is. I mean, I think this report was a really brave attempt, and I think Anne would probably agree with that definition, to try and bring together a very wide range of disciplines in writing it. I don't know whether it is the first report that's been commissioned which has had social scientists, ethicists, consumers, as well as scientists, and I may indeed have left a category out. But I think as a model, that is actually really interesting and quite a good way forward. I mean, I would not pretend that I understood everything that was going on. I really did not. But, you know, I did manage to grasp some of it, at least the basics. And I think the importance of having not just me, but Nick, who's in the audience somewhere, Nick Pitchin and Honora O'Neill, who I don't know if she's here, but this sort of range of other disciplines coming in, was that I think consumers are actually pretty worried about science, and that's a terribly anodyne thing to say, but science is going really fast, and consumers can't keep up. And actually, the whole question of moral, social, ethical issues is not very often discussed around science. And yet, in the end, once the scientists have invented and the technologists have applied, it is actually the public who both buy, benefit and suffer. So I think because of past problems, I mean, notably GM, I think there's increasing feeling among the public that they must be included in the discussions around how science is framed, how it's governed, for what use is it going to be put, who is going to benefit from it. And I think this report was a really, as I say, a very brave attempt to start looking at these issues in a very different way. And, of course, one of the important recommendations that came out of that, which, of course, I now can't find, but it is essentially that the government should fund a really good public debate around this science. Actually, public debate's a bit of a one-sided thing because it suggests that scientists are there and the public debate it somewhere else. Actually, what I think we're really getting at is good interactive discussion between the public and scientists about what's going on. And I think I'm very pleased with that recommendation.
Doug, NGOs like Greenpeace are often sort of left out of these things until a new technology is up and running, and all you're left to do then is either say nothing or to come out fighting. This is really hardly had much of an outing. There are some nanoparticles already out there, some nanotechnologies in use, but they are ahead of the curve in this. What's your reaction to the report as you've seen it?
I thought there was a lot of good stuff in this report, actually, and I thought it was a good and innovative move to try and tackle the issues right up front, as well as just dealing with the science. I think I very much welcome the stuff on nanoparticles about treating those with considerable caution, certainly more caution than they're treated with at the moment, and about the need for regulation to deal with that. And I think it was a great starting point for some of the much bigger issues. There was a good exposition about the need for public debate, about the need to look at social and ethical issues, and it's really a platform for having those kind of discussions and the role of government, companies and others in those.
I noticed that the social and ethical issues were rather pushed into the long grass, weren't they? I mean, this was a working party which basically said there ought to be a working party looking at social and ethical issues.
That's why I say it's a platform. I mean, it didn't come to any sort of detailed conclusions, do this, that and the other. I think the working party would probably say, well, it wasn't our remit, and, you know, okay, fair enough. But maybe we can start doing that now.
Yeah. Ian, have they been looking forward far enough?
I found this report very frustrating because it's full of very sensible recommendations. It's very hard to disagree with it. I don't think it went quite far enough for my liking. I would have liked it to go further. I mean, the report says in a number of places this isn't going to happen in the foreseeable future, and that's fine. No, it's not going to happen in the foreseeable future. But I think some of the very long-term issues are so important that it's really time we started looking at them now, because it'll take us a long time to figure out how to deal with them. And for example, it dismisses the grey goo problem, which is nice. I'm quite happy that that's not going to happen. But the issue of self-replication, I don't think, can be quite so easily dismissed.
These are molecules that have the property of DNA in that they can make copies of themselves.
The idea of the grey goo problem is you get little stainless steel robots that make replicas of themselves. And none of us really believe that's going to happen. On the other hand, scientists are becoming quite adept at getting nature to do things for them. And I can sort of imagine, in the not very far future, people have already made polioviruses starting basically from scratch with just a listing of which genes you need. Who's to say that we can't harness the biological machines that already exist in nature to do the self-replication for us? I think that we dismiss these sorts of things a little bit too easily in this report and say it's very far future. Maybe it's not quite so far future as we're making out. Maybe it's a little bit closer, and I would have liked to see some of those issues looked at in more detail. But I'm not suggesting that grey goo is a possibility, but going somewhere along that self-replication line I think is more likely than the report makes out. Other than that, I really couldn't find any real faults with the report.
Okay. Look, before we go on, Sir David King is down the front. I don't know if you want to say anything, David, or whether you're sitting very quietly because you want to be in listening mode. I mean, do you want to give any reaction to it?
I'm happy to be listening.
Happy to be listening. Okay. Who wants to speak? Yes, please. If we can, please, whoever's got the microphones, we can try and get them to people as soon as you see a hand, so that we don't have waiting around while we get. In fact, I think, have we gone off to get microphones? Or? I'm not sure. I think there is a microphone. Is there a microphone stand over there? And it's all right, somebody's coming to you. It's all right, if you'd like to go over there. Can I just see who else would like to ask a question? Or please make a comment. As I say, I think British society has gone beyond the time where the great and the good are on the platform, and the rest of society is merely allowed to ask questions. If you've got comments, views of your own, it'd be good to hear them. But briefly, please, everybody, so we can get through as much as possible.
My name is Jim Kennedy, as an octogenarian no longer affiliated. One of the risks cited, I believe, in the report, which was most disquieting to me, concerned the possible inhalation effects, and notably the drawing attention of a certain degree of similarity between the structure of a nanotube and asbestos fiber. I wonder if one of the panelists would comment about that.
Anne, you have already expressed on behalf of the working group some concern about this.
Yes. It is something that the working group had concern about. As I understand it right now, mostly nanotubes, when they're produced currently, which would be predominantly in research labs, they come out like bundles of cotton wool. One of the current challenges is to get nanotubes to be separate. So right now we don't think there is a major risk of inhalation, but HSE have introduced some interim guidelines which we're supporting, and we would really recommend that all labs carefully review exposure to nanotubes. But right now they're mostly in knotted bundles and perhaps not likely to become airborne. But in that form they're not that useful. And one of the current research challenges is to make nanoparticles be separate. And there's a lot of activity going on in that area. When that happens, then there'll be individual fibers much more likely to be airborne, and people will need to be very, very careful. So it's not panic stations at the moment, but it is absolutely the right time for labs and manufacturing plant to be taking the right precautions to ensure that their workers are not inhaling the tubes, and putting good practice in place now will be timely for when they get this current hurdle overcome and the tubes are more likely to become airborne.
Do you want to add something to that?
Yeah, well, I think the inhalation risks from nanoparticles and nanotubes are, we can argue by analogy with what we know from air pollution, where we know nanoparticles, ultrafine particles as they're described, are an issue. And that's why I was very happy to see the proposals about regulation in this report, because I don't think the scientific challenges of trying to look at nanoparticles and nanotubes in the same way as we look at chemicals should be underestimated. We don't understand the way in which these things interact with biological systems like ourselves. There is a huge amount of work to do. And the question that arises in that context is what you do in the meantime. Because one can see a developing industry around the globe, big production going on in Japan on nanotubes, likely to kick off in the US, it's happening here in the UK, nanoparticles at any rate. What do you do in the meantime when you've got that level of uncertainty and you've got that level of kind of, well, not danger because we don't know, but you've got that level of uncertainty. And that's why a couple of the recommendations seem to me to be quite key, which is that they should be treated as being hazardous such that the emissions and dispersal of free nanoparticles should be minimised or avoided altogether. Not because we've got a risk assessment model that shows they're dangerous, but that's what we should do because that's the way we should look at it in a precautionary way. Okay, I'll stop there and let somebody else have a go.
Yeah, very helpful. Anybody else, please? Yes, right at the back, and there's also somebody just by the edge there, if we can get micro. Oh, and just here, too. So I'm going to leave it to the microphone carriers to select whoever they see. And whoever's got a microphone, if you'd like to speak, please.
Jim Thomas, work for Etc. Group. And we've broadly welcomed, as an NGO, we've broadly welcomed parts of this report, particularly the parts on nanoparticles. And it's very good to see the Royal Society, the Royal Academy of Engineering, talking in a precautionary way about the risks of the sort of health risks and environmental risks of free nanoparticles, and particularly pointing out how poor our knowledge is in this area, that there are massive knowledge gaps as well as very clear regulatory gaps that have to be filled before it's possible to bring nanoparticles to the market. And in some ways I'm following up from what Doug said, that in fact I disagree with what you say, Nick, that we're ahead of the curve on this one. There are already hundreds of products using nanoparticles, and they range from food additives and cosmetics additives right through to things on bandages that are applied onto the skin, and a lot of industrial coatings and so forth, which have end-of-use questions as well. So far from being ahead of the curve, we're actually slightly behind on this one, and this shows we have concerns with potentially products already in the market. And where I sensed a very clear fudge in this report was what to do about those products already in the market, given the lack of knowledge and the lack of regulation. And with Dr. David King here in the audience, I'd love to hear from members of the panel what they think should be done with the products already in the market, given the precautionary approach and concerns of potential hazards.
Deidre, as I read the report, you didn't seem overly concerned about products already on the market, largely because they, as Anne was describing with the Pilkington product, the glazed product, the self-cleaning windows, as it were, they're locked in. But there are others, we're now told, which aren't.
Yes, I think that's right. And I think the use of nanoparticles in cosmetics is something that could well come back to. I mean, I think there are two issues here. One is the regulatory issue, and the other is the public acceptability issue. I think on the regulatory issue, what we generally felt about regulation was that we have a framework approach to regulation. So that actually, potentially, there was a regulator to whom most things that we looked at were applicable, would be covered by. I think the more important issue is how those regulators are, as it were, sensitised to what they should be looking at. And it was quite encouraging that HSE was already looking quite broadly.
That's the Health and Safety Executive.
Sorry, Health and Safety Executive was already looking. This is such an educated audience, for goodness sake. But I think of the figures in the public research who knew about nanotechnology. This is not a typical audience. But so they as a regulator have already been sensitised to some issues. But actually, I think the thing that is slightly worrying, perhaps, is the lack of sensitivity is the only word I can think of to the sorts of issues related to nanotechnologies which are coming up, and therefore what regulators ought to be looking at. I think the public acceptability issue is an interesting one, because funny enough, people have said to me, oh, I've heard about these things that go through the skin. That doesn't sound very good. And then you say that's nanotechnology, and they say, oh, is that what nanotechnology is? Crumbs, So I think there's going to be some very difficult discussions around this, because it's such a ubiquitous technology, as everybody said. I think it's going to be very, very difficult for the public to get a handle on it and decide on whether they're happy or not happy. It's going to make this a very complex debate.
One of the recommendations of the report is that there should be an interdisciplinary research centre, and it should be set up soon, and it should start looking at this sort of stuff as quickly as possible.
And actually, can I just say one of the other recommendations in the report was that we need some kind of horizon scanning capacity so that we can see what new things are coming over down the motorway over the hedge, so we kind of can grab them early on.
We're getting a microphone down here. I think
Can I just comment,
please.
Because we didn't find evidence that there were nanoparticles in food in the UK, and only very limited amounts in cosmetics, in fact. And the one that's most used in cosmetics is titanium dioxide nanoparticles. And that's gone through exactly the sort of independent safety assessment that we're recommending, because current legislation requires that UV filters go through an independent safety assessment.
So it would be wrong to wake up tomorrow morning to health scare headlines saying, watch out, the nanotech particles are already out there and getting at someone near you.
It would be wrong to assume.
Okay. Whoever's got the microphone, please, and someone down here and then someone back there. Please, sir.
Yes, I actually wanted to caveat to what you had mentioned, Ann Dowling, about the toxicology. And my question, I guess, was specifically, like, as you have in U.S. EPA, they have a protocol that you would follow for how much arsenic or the European directive would have, how much arsenic you could take in. I guess the same question is how much carbon nanotube that you could take in. So as you know, carbon could, and the raw material processing, contain nickel and other things like this. So how would you, I guess, regulate those?
And presumably it could be, I don't know if any of the panel knows the answer to this, but perhaps it could be a bit like smoking, where you can never tell. You can say on average it seems to be worse if you have more than 5 or 10 cigarettes a day, and very bad if you have 20, but we can't even say it's safe to have one. Or there may be a threshold beyond which these things have no physical effect. We don't know, presumably, do we? Doug?
Well, I think, yes, I mean, very likely it is going to end up like that. I think that what's interesting about this is if you don't trust the scientists, follow the money. And Swiss reinsurance have put out a very cautious appraisal of any nanotechnologies that involve dispersive uses of nanoparticles. Whether they would actually be prepared to grant insurance to a company producing those, I'm thinking particularly in relation to things like smoking and asbestos. They don't exactly come off the fence, but they're nervous about it, to say the least.
Of course, the insurance business can be over nervous. I have in the loo in our house the first an early insurance document for our house, and the cost of adding to the insurance a little clause saying should an aeroplane crash onto the house was almost as much as the entire insurance for the house. They were expecting aeroplanes to crash onto houses every 5 minutes, mercifully. Great. Yes, please. And can we get the microphone? There was somebody with that. Oh, you've already got someone, and then someone back there, please.
George Smith. I'm an academic at Oxford University. I also run a company called Oxford Nanoscience, so I hope to declare an interest in this field. I'd like, first, 2 comments about nanoparticles, and then something about the recommendation. First of all, can I echo what's been said from the platform about the new and different and unexpected properties of nanoparticles. The classic example that I put to a parliamentary committee last year was silver nanoparticles, which are known to have strong antimicrobial properties. They're used in preventing wound infection, for example. They can also be impregnated into socks to prevent smelly feet. So it's the acceptable size of nanotechnology. But the flip side of this is that silver nanoparticles kill things. And to take the words of the Secretary of the British Microbiology Society, there isn't a toxicology test known to man that you could apply to a lump of silver that would predict that a nanoparticle of silver would behave in that way. So that there is genuine cause for concern. On the carbon nanotube side, well, things are moving very quickly. Landing on my desk today is this week's issue of Nature Materials. And on the lead article in this is a way of synthesizing single-walled nanotubes, which are up to 4 centimeters long. So unbundled nanotubes, have effectively arrived on our desks.
George, can I ask you a question? I don't know how big your company is, but if in nanotechnology it's anything like biotech, some of the most innovative companies are very small.
Yeah.
And whereas big companies can embrace and get their heads around and have compliance officers for regulation, small companies often struggle with it. And I just wonder if some of the recommendations worry you.
Yes, well, this is. I wanted to then come to the key, what I think is the key recommendation, number 3, in the main report, which is to set up this IRC to coordinate precautionary research. Now, I think this is extremely important, and it has to be done at a national and international level. Yeah. There are really 3 key aspects to what the panel has recommended. One is that there's got to be some money spent on this. Secondly, slightly unusually, it suggests that it should be RC UK, the Research Council's UK, which coordinates it. Thirdly, very clear strand right through the report, what the work that should be done should be totally independent, standalone, peer-reviewed, published, open, transparent. And I do hope that we can keep the pressure up here. You don't have to be a rocket scientist or indeed a nanotechnologist to second-guess the government response to this. The concerns are, first of all, the government will say that there will be no new money. Second, anything that speaks of independence and openness may send a few shockwaves through. You can predict as a dead cert there will be an attempt to say, well, nanotechnology is so important, we must take this in-house. There are several government departments that are going to be involved, environment, DEFRA, etc. We will split the responsibilities between those departments. Everything must be done out of existing budgets. And basically the entire report will be shoved into a siding and will be derailed. And if it does go in-house into government departments, the big concern there is that everybody inside those government departments is essentially covered by the Official Secrets Act. And the risk we have is that what happens in nano is what happened with GM technology, where it was buried in the Department of the Environment, and the only stuff that came out was what the civil servants and the government officers wanted to come out. I think that this group has made a very, very important recommendation that the safety work and the appraisal work should be open, peer-reviewed and accessible. Many of us who had profound concerns about GM technology was not because we knew it was necessarily dangerous, but because we were not able to see that it was safe. In some cases, the precautionary work hadn't been done, and there was very, very little in the public domain that we could scrutinise and look at.
I don't know if you've been trying to provoke Sir David into responding, but I'm sure he'll choose his own time to do that.
Could I just
Ann,
just comment there? I think it's an important point. What we're talking about here is really developing a new toxicology. We have a toxicology for large particles and chemicals, but this is where they might react differently. There's a whole new field to develop, and we really can't afford the resource to duplicate that. One of our recommendations is, in such a publicly funded lab, they should maintain an accessible database of this toxicology, because this is all pre-competitive. The other aspect that's really going to be important is to link up internationally in doing this. And last week I was visiting people in the US about this. They were really very enthusiastic with the recommendations of the report, and were saying this is something they'd like to see on the G8 science agenda, to actually get international collaboration towards developing this new toxicology. And I think this would be a really good way to move forward.
Right. I was interested that George, actually running a business in this area, doesn't see the recommendations and the potential of constraints looking at things as potentially toxic and all this, doesn't see it as a constraint on his business, actually sees it as an emancipation, as something that's got to be in place if this industry is to thrive. Deidre, from a consumer's perspective?
I agree with you so much. I think what you said is utterly right. And there is, if science is to move forward, there is a kind of compact, unspoken compact that has to exist between the scientists and the public. And because the public are very often not able to make a judgment about the validity of the science itself, what they use as a proxy is independence, governance, where does the money come from, in whose interest is this being developed. And unless that is utterly transparent, then the public start to ask questions and wonder why it's being kept from them. And you're absolutely right. I think that was one of the fundamental problems about the GM debate.
Yeah. Though, in fact, the government has just announced, I think it was Lord Sainsbury has done a review of all sorts of independent committees that there are, which come out with all sorts of ethical issues and answers in science, and has decided that they're not going to be brought in-house, that it is much better if a lot of it is done externally by people who are plainly independent of government. We've got somebody with a microphone there, and I can now see a lot of hands going up. But there is somebody, after that, please, in the middle of the block, who's been waiting for some time. Yes, please, madam.
Hi, my name is Magdalena Muir. Some of the comment I'd like to make, or question, is going to follow very much on the last one and the discussion. I'm very curious to what extent within the UK, whether government or an independent group can determine what happens given the European or international, both regulatory and commercial aspects of it, even to the extent of controlling the UK entirely as a market. And on the commercial side, from working quite extensively in markets in North America, it's very difficult for people not to start looking at the commerciality of information and disclosure. And you'd see resistance in biotech or pharmaceutical companies to the kind of disclosure you're talking here. At least the large-scale ones in North America, regulation, and often the science provided now is done mostly by the commercial entities in that venue and not by independent scientists. So just some comments.
In medicine, of course, I mean, you Anne, were talking about the pre-competitive stage where disclosure is not a problem. But if you look at medicine, and particularly pharmaceuticals, as we've just been told, I mean, their government has had to get in hard and fast. And we've got the European Medicines Agency, we've got the FDA in the States, and they are increasingly having to be proactive with pharmaceutical companies and actually forcing disclosures of more and more stuff. And now they've got to the point where they're saying, we're not even happy that you tell us about your trial results. You've got to tell us at the beginning that you're launching the trial because you bury bad results. Is that going to happen in this area as well?
Well, I think there are various aspects to that question. What we are talking about, first of all, is developing a toxicology understanding, measurement techniques, and that's very pre-competitive. Industry is already beginning, right now regulation is not in place, and industry is already having to set its own standards in this area. And we have heard from industrialists that they would welcome more guidance in this area. Some of the large companies have already begun to get together to talk about how they, for example, should protect their own workers, and they're exchanging information there. So I don't think in this area of HSE exposure of workers to nanoparticles, nanotubes, that companies feel that they're in competition at all. And they would certainly welcome more research in this area, but also welcome regulation, which actually helps set uniform standards for them.
It's got to be on an international level. And if you take a company like BT in, many of your products and services are really on an international basis. When someone develops anything in the telco business, it's a global issue.
I really do think this is a threat that if people are forced to make things public, even when they're starting to do some research, that's a deterrent. If I'm thinking about some new product or service and I think that there might possibly be some risks, it's very disadvantageous for me to make those risks formally known by suggesting that there might be some, and then going ahead and doing some real trials and research and stuff if I've got to publish all of that. If I just pretend that I'm not aware of the risks and carry on developing the product, and don't publish any research and don't do any research, that's a faster route to market. So there's a disincentive. Now, how you balance that, I don't know. I mean, can you force me, unless you've got some sort of brain scanner, how can you possibly know what's inside my head that I choose not to bother telling you? You can never force somebody to start doing that research, and we have to find a way of getting people to publish the results in an honest way without deterring them from doing the research in the first place. And that's a difficulty, especially on an international platform, because if I'm in Europe and I do this stuff in a very ethical way, as I hope we would do, BT tries to do that and stuff, but if we do it in a very responsible, ethical way in Europe, and in the States they ignore that, or in the Far East they ignore that and just charge ahead, then we end up buying the products anyway, and our ethics comes to nothing. So we have to get, I think, better internationalization of this. We have to find better ways of working with other regions and get some more global regulation. And this sort of report's a good example to other regions, and hopefully they'll follow it. But there's no compulsion on them to follow it. How do we get this to be accepted by other regions in such a way that everyone works on the same playing field? Otherwise, Europe is set at a disadvantage.
George, I know you want to come in. I'm just going to try and capture some other thoughts and questions if I can. Yes, I see you. Have you got a microphone already? Somebody has also been waiting for time behind you, and then we'll come to you. I don't mind who's going to go first. Would you like to go first? Actually, you've been waiting longest. Would you like to?
Thank you. My name's John Robinson. I'm a health and safety advisor in the University of London. I'd just like to make one comment about the last comment about risk. I think one of the things we have to accept is that risk assessment is not the same as risk aversity. You shouldn't be necessarily averse to taking risks. You should be able to assess the risk and then make a sensible judgment. That's wearing my health and safety advisor's hat. The other point, it's a technical point really. An important property of a toxic compound is its ability to penetrate into cells. And I just wonder if anyone here with a better technical grasp of these things than me has any comments to make on whether these nanoparticles in particular do facilitate or accelerate the uptake of toxins or even the particles themselves in cells, because to do damage usually a chemical has to get inside a cell in the body. If anyone would like to comment.
I think one of the fundamental reasons you've called for research, Anne, is because not enough is known about this.
I think there's evidence that some nanoparticles can penetrate cells, but there are better defences on the body, so they don't necessarily penetrate the skin or the lining of the lungs, but sometimes they do. But Anthony Seton was on our working group, and he's got his hand up. Maybe he
Anthony,
would like to come in
I wonder
here.
if we could just take the microphone. We'll bring it back to you just one moment. Anthony, could you just put your hand up so they can see you? Thanks.
Thank you. I was the person who dared to put the word asbestos into this report. Yes, nanoparticles, some of them can penetrate cells. They can certainly penetrate the cells lining the lung and go through them and get into the bloodstream. We know this from air pollution research. There is also some evidence that they can penetrate the nerve fibers in the nose and get into those. So there is, I think, little doubt that if they're small enough, they can actually get into cells. Whether they do harm when they get into cells is not known, but it's possible.
And what's your view, since you know about this? Are we becoming incredibly wimpish as a society? I mean, we've all, as infants, death in infancy has, been largely eradicated. We're getting older and older and not dying till we're in our 80s and 90s. We're losing almost nobody in wars compared to hundreds of thousands that we used to dispatch earlier, at least of our own population. So we're even getting anxious about killing the enemy nowadays. What's your own view? How worried should we be as a society about these technologies?
Well, my view, of course, is that the younger generation is extremely wimpish, and including my children and grandchildren. And I'm sure most people in this room share that view. But seriously, toxicity doesn't just depend on the toxic potential of a substance. It also depends on the dose, and that was known in the 14th century, and it's still true. For example, someone who gets a serious asbestos-related disease has over 1 million fibres of asbestos in every gram of their lung. So whereas one can never say there is a safe level, you clearly do have to get a fair old dose of many of these things. And one of the reassuring things at the moment, and it is only at the moment, is that not many people are exposed to not very much nanoparticles and nanotubes. But that raises the other issue, because we don't really know how much people are exposed to, and that's the other limb of any research that's got to be done. We've got to look at how much people are potentially being exposed to in different situations, as well as the inherent toxicity of the material.
Okay. Now, I promised we'd take the microphone back to whoever it was back there, yes.
I'm Marv Baxendale from Queen Mary, University of London. I'm one of these people that's attempting to make electronics from carbon nanotubes. And in the laboratory situation, we do indeed handle carbon nanotubes with great caution. However, that's not my greatest concern. My greatest concern is uncontrolled production of nanotubes. To produce a nanotube is remarkably easy. What you need is elevated temperatures, hydrocarbons, and pure metal surfaces, precisely the conditions that occur in combustion engines and jet engines. Anecdotally, I spoke to somebody several years ago who was exploring possibilities of recycling waste products from jet engines to extract the nanotubes to fulfill the needs of those people that want large volumes of nanotubes. So I wonder if the group, during the writing of this report, considered this. I'm often curious as to where the greatest nanoparticle count will be, in my laboratory or on the traffic island in the road outside. Also...
Sorry, just before you... Yeah. Do you accept that what Anne was saying earlier, that at the moment, when nanotubes are produced, they tend to come in sort of cotton wool clouds, not the individual ones?
That's correct. And we're attempting to do electronics. We need to isolate individual nanotubes. The methods we use are very crude at the moment. But in the case of electronics, that's usually in a very controlled environment. At the moment, we manipulate nanotubes on a surface with a scanning probe to put them into position on the circuit. But to get back to the point of what I'm trying to say is combustion products are known to contain carbon structures, not quite on the nanoscale, but there must be some nanoscale component in there. Particularly if it's a byproduct of from jet engines, that would strike me as an extremely effective way of dispersing nanoparticles in the atmosphere. Is there any reports out there that I can look at, or does anyone have any information on that? And did the people that composed the report come across it?
Doug, do you know anything about this? Are we already being bombarded with street? Anne, do you know?
Well, the products of combustion do produce nanoparticles, and there is actually quite a section in the report. We've been inhaling the nanoparticles from combustion ever since we started cooking, but perhaps even before that with volcanoes.
Not just jet engines. I mean, this came along before Frank Whittle.
Yes, so pollution in streets, and we give some figures of several millions of nanoparticles per breath in a typical urban environment.
We're already breathing several millions per breath.
Of pollution nanoparticles. Mm-hmm. They tend to be fairly benign types of... well, first of all, there's evidence that they do cause some health hazards right now. Our concern with manufactured nanoparticles is a range of particles that are more reactive than carbon being produced, and coatings which would alter their ability to penetrate the body's defences.
Yeah.
But it is well known that there are already pollutant nanoparticles out there.
Okay, yes, please.
My name's John, and I'm visiting from Australia, and it's encouraging to see that there is a debate starting to take place here, and it's missing from back home. But I just wanted to reiterate the question that was asked earlier on, just about the nanoproducts or nanoparticles that are already introduced through commercial products and how to regulate those, because I didn't feel that question was answered clearly.
Mm-hmm. Did you feel a problem in this? Is this an area you looked at, Anne?
Yes. So what we have asked is that regulation moves so that when consumer goods contain manufactured nanoparticles, that the safety assessment is done by an independent advisory body. We would like that put in place very soon. Currently, it's up to manufacturers to ensure that their products are safe. And what we have asked, one of our recommendations, is that manufacturers should publish the methods that they've used to establish the safety of consumer products currently containing nanoparticles.
So
we don't think this is a big area. There aren't many products on sale in the UK.
But do you think this is going to move to the equivalent quite quickly of setting up a major institution like the FDA in the States or the European Medicines Agency?
When we take the case where the UV filter has been approved and titanium dioxide approved from that, it was really approved on the basis that it didn't penetrate the skin. So relatively straightforward tests there were showing that on healthy skin it was safe. Now it could well be on other products, manufacturers have done the right testing. But because it's their assessment, we don't know what methods that
we don't know if
we're asking them to publish that.
Thought about it going onto the lips and therefore being ingested and things like that.
That's right.
So regulation of this external regulation as soon as possible for the stuff that's on the market.
And before that,
we
would like manufacturers really to voluntarily publish what methods the methods that they've used, not the results, but the methods they've used to establish the safety of their products containing nanoparticles.
Okay, thank you. Yes, George, I know you want to come back. I will get back to you, but I want to try and get some other people in first, please.
I'm Vicky Stone from Napier University in Edinburgh, and I suppose you could describe me as a nanotoxicologist, and I did actually provide some evidence to the panel for this report. Rather than asking a question, a few people have asked questions of the general audience. In particular, there was one question about, can nanoparticles interact with other potentially toxic substances to make them more toxic? And there hasn't been a lot of research done on that, but there is some evidence to show that nanoparticle carbon can interact with metals, and you see a much, much bigger toxic or inflammatory effect in the cells that are treated than if you added either of the two things individually and then added those responses together. So they enhance their toxicity. Similar studies have also looked at allergens, so proteins that can cause allergy reactions, and the particles from combustion sources such as diesel and petrol engines, they can enhance the delivery of those allergenic proteins and cause allergy in a number of models.
Okay, thank you very much. Thank you very much for that. Who's got a microphone now? Somebody, yes, at the back? And somebody, yes, just down here in the third row, please, next. Yes, please.
James Alston from Demos. We're a think tank that's very concerned with the health of democracy and interested in science in that regard. And we were very pleased with the progressive and positive note in the report around the importance of dialogue with the public. What I wanted to ask the panel, and particularly Deidre and Ann, is sort of how that dialogue process should now proceed, and particularly how we ensure that that dialogue doesn't collapse back into a fairly technical discussion that we're sort of sliding into this evening around the toxicology of nanoparticles, but actually keeps at the foreground the very fundamental questions that you raised, Deidre, around who owns the technology, who controls it, and actually who needs it in the first place. To what purposes will this technology and these technologies be directed, and how can we have a wider public and democratic discussion of those questions?
Well, Deidre, do you want to have a go at that? And I think Nick Pigeon is in the audience, who was on the Working Party. One of the difficulties, Deidre, of getting any public debate is that we in the media are only really interested in these issues once they become controversial. And it's only when people are fighting each other that they tend to get onto the, into the headlines, that lots of other people read about them. If you are thinking about this and being rather pensive and thoughtful, it tends not to be deeply controversial. People tend not to fight each other, and therefore you can't stimulate a debate very easily. It's a bit of a catch-22, isn't it?
Well, I think there's some really serious problems with the media. I do not blame the media for everything. I really don't. I think actually all of us need to try and certainly not be frightened of the media, and secondly work with the media and build up good relationships with them. Because actually I think the most successful interactions you have with journalists are where you've had a conversation with them over quite a long period and they become interested and informed. That's actually very hard work. For the institutions or the individuals concerned. I think there is a fundamental problem that we don't have nearly enough journalists who actually have a scientific background. So on the whole, I think one of the reasons why you go for the crisis or the controversy is because actually you haven't been fundamentally interested in the science because you come from an arts background. Now, so do I come from an arts background, so I'm not knocking it. But I think if you look at the number of scientists per newspaper in this country, I think it compares very, very badly with some other places in the world. But the point you make about the public dialogue, I mean, I think the first thing to say that there isn't one answer to this. There is no one perfect form of public dialogue. It is about every institution and every scientist and every school, as well as journalists, building it in as a normal part of the way in which they operate. I mean, we did hear at one stage during writing this report that in, I think it was America, if you get a grant for doing a particular piece of scientific research, you are also required, as part of that work, you have to guarantee that you will go out and talk to people for a proportion of your time. Now, it seems to me it's that kind of interaction that scientists, first of all, need to get out there and talk about what they're doing and be sensitized to what the public think and believe. Because there really are fundamental issues. I mean, it came to me as something of a surprise, and I'm going to probably offend lots of feelings here, that somebody who was deaf would not want to use the benefits of nanotechnology to be made not deaf. Actually, there are really strong ethical issues around that. And we need to consult people who are deaf to know how they feel about it. So it's these kinds of issues where I think for scientists, what's out there in the public is not necessarily expected. And you need to get out there and talk to people and find out what they think. As well as that, I think that there has been, again with GM, a really good attempt to start a public debate around that area. But Nick was very involved in that and knows far more about it than I do.
Nick, can you put your hand up so we get a microphone? Oh, we've already got a microphone to you.
Thank you. Yes. Well, what I would say is to reiterate Deirdre's words that I think our experience as sort of non-engineers and scientists on the committee was interesting because there was a genuine dialogue around the table. I think Deirdre would agree with that throughout the process. So I've often been asked, well, which bits did you agree with and which bits did the engineers disagree with, etc. And that definitely was not the case. So the committee and process was a process of dialogue. And what we've said is there isn't any one way. And there isn't any one way because nanotechnology, as Anne has pointed out, is many different things. And it may well be that the applications that are really ethically tricky we haven't envisaged yet and will come across us maybe suddenly in 10 or 15 years, in 10 or so years' time, which is why we've called for this horizon scanning body from the Chief Scientific Advisor's Office to really keep an eye on these things as they come along. What I would say is the challenge is not just for government. What we've said in the report is that there are a whole group of organisations and individuals in society who ought to be taking this dialogue forward, and it should be appropriate to the particular issues at hand. The one that we've highlighted in the report is the issue of governance of nanotechnology. And it's interesting, actually, since the report was published, I think that's probably the thing that's had the less discussion publicly in the meetings that I've been at, and it would be nice to have that opened up in a wider sense, because I think there are some very profound issues about who wins and loses in the short and long term, whether some of the claims about benefits to the developing world, etc., really will be borne out by the short-term and medium-term development of the technology. So I think that's an absolutely critical issue that has to be taken forward.
Thank you. Doug?
Yeah, I'm really glad we've got onto this, and one of the reasons I wasn't banging on about nanoparticles more is because I think one of the key things from this report is about that public engagement, that kind of dialogue, and how we take the technology forward in the future, to what purposes it is going to be put. Greenpeace actually would like to be really in favour of nanotechnology because there's a lot of possibilities there for, say, cheap solar power, energy-efficient lighting, all sorts of things which have been identified. They're not immediately going to happen, it's true, but they could happen. And we have this massive problem called climate change, which is one of our distinguished guests has pointed out, is a bigger threat than terrorism in the longer term. Now, I would like to be able to see nanotechnology delivering tools with which we could deal with those problems. But it doesn't feel to me like the existing governance arrangements are going to deliver that. If you look at the lessons from GM and touching on this public debate issue, I don't think we necessarily need to have a public debate that involves lots of people turning up to drafty church halls on wet Wednesdays in order to try and learn something about nanotechnology. That's one version of it. But eliciting public values to feed into the decision-making processes around scientific priorities and agendas is something where there are a lot of mechanisms. It's just a matter of finding the right one, finding ways of understanding the insights and incorporating them into the decision-making, and of the decision-makers to be willing to hear and respond to them. And those things that came out of the GM debate, the things like, why do we need GMOs? Who's going to get the benefit? Is it all going to go to American multinationals and not us? Who's going to be responsible if things go wrong? These are well-established things that were happening at the public level, even if not in those terms. How are they going to be incorporated into the way that nanotechnology develops? And in the effort to try and say we're not going to make the same mistakes as GM, I think this report is really valuable in setting down some markers on that. And I think the challenge, as Nick said, not just for government, but to go beyond government to include companies and other, yes, even the media, although, I'm not, I don't think we should have a discussion about the media, frankly, because there are other things to focus on. How are those people, how are those lessons going to be learned, acted on and delivered in such a way that there is public support for nanotechnology and, as I say, the potentially good things that can come out of it?
Can I press on? It's really interesting what you said, because so often these debates are characterised by the very British adversarial approach, Punch and Judy. And what tends to happen is that Greenpeace is cast in the green corner and the industry is cast in the red corner, and you battle it out. If you can collaborate, of course, it's much more likely we're going to get a much more civilised and intelligent debate. On the other hand, isn't there a danger that Greenpeace supporters don't really like this? They see this as muddying the waters. They see this as you playing with the enemy. In taking what some people would regard as a more considered role in this, I would say our role on GM was actually quite considered, but hey, not everybody would agree with that. I do not feel any pressure whatsoever from our supporter base or other people inside the organisation to somehow be, banging some mythical drum about how dreadful everything is. In fact, the support we got when we ran a series of debates with New Scientist a couple of years ago about future technologies was very, very positive. It's like, it's really great that you're doing that and trying to explore some of these difficult issues about how we govern technologies in the future, how we make real choices. One of the things that I say, actually, is with tongue only partly in cheek, is who made the biggest difference to people's lives today? Was it the premiership of John Major or the widespread uptake of the World Wide Web? And we spend a lot of time discussing and electing and dealing with one issue, and the other one just kind of happens. And whether it's right or not, I think the World Wide Web is great, but whether it happens or not is just kind of happenstance. It's just like, well, yeah, somebody decided it was a good thing and they invented it and it just all happened. Now, it's not abundantly clear to me that everything that will flow from nanotechnology is going to be good. I think there can be some good things, but there could be some pretty awful things. And how do you get one without the other? And how do those public values about, cleaner environment, about proper public health, about socially progressive technology tools, how do they get incorporated into what we do at the R&D stage? And that's a big question, and I'm really glad that this report's flagged it up. Okay, there are a lot of people flagging up their eagerness to participate. Who's got the microphone at the moment, please? Yes, far away.
Hi. Sorry, I would like to ask a question as a member of the public and a consumer of cosmetics. You said that you think manufacturers should publish the methods they've used to establish safety, but I don't think that this would mean a huge amount to a normal member of the public who isn't well versed in the best toxicity test. Would you recommend a labelling scheme, or do you think that this would be alarmist and something that you would hope to avoid?
I don't think necessarily that every member of the public will indeed be able to understand the precise nature of the toxicity test. But the point is that somebody will. Greenpeace will. Somebody will understand how it works. So if it's in the public domain, you can be pretty damn certain there'll be somebody there who's going to read it and understand it and blow the whistle if it's dangerous. But I think it would be unreal to think one could publish data that everybody could read on a label. I mean, actually, you'd need incredibly good glasses to read it in the first place. But I think the fact that the critical thing is that it is in the public domain, and we do think that's really important, and that you should know as a member of the public if something's made with nanoparticles. It should not be a secret. Secrecy just breeds trouble.
Can I just say,
the important thing for the consumer would be to know that some independent scientific advisory body had said it was safe.
And the danger,
and then after that, you don't have to worry.
The danger
you don't have to be an expert.
is presumably is that if
I don't think the public works quite like that, actually. I think the public do indeed want to know that there are independent advisory scientific groups there. But actually, if you look at who the public trust, they also trust NGOs to blow the whistle. Mm-hmm. So I think it's a combination of poacher and gamekeeper that actually leaves the public feeling relatively reassured.
Of course, a self-revelation by companies. Companies are bound to put the best possible gloss on the safety testing they've done, aren't they? It surely can't be ideal, Deirdre.
Well, I mean, I think Anne is right. I mean, anything that a company says about the safety tests it's put out there, those safety tests will have to be satisfactory in terms of whatever the framework the regulator has laid down. So I don't have too much hesitation about that, provided the regulators are doing their job properly and are independent. I just think that there is a layer beyond that the public trust other people as well. The public do trust Greenpeace. They believe Greenpeace do some important whistleblowing on their part, and I think actually history. Look at it, they do.
I've just realised it's almost 2:15. We should be stopping now. I'm going to take just 3 more, and there's been somebody there who wants to speak. Somebody's already got a microphone there, and there's yes, in the black. Have you already got a microphone? Okay, going to come here first, please.
Thank you. My name is Mike Rogers from the European Commission. I think we didn't pay enough credit to the panel for producing an excellent report. And having just done a similar job in Brussels, I have to commend you on a report that's legible, readable, and intelligible not only to the scientists, but also to the general person. And I think that's a very big step forward in this debate. I'd like to make 3 points. In the 10-page summary, Europe gets mentioned 5 times, which in UK we're always grateful for, at least in a positive light. But then you mention also creating the debate, creating the process of taking the recommendations forward, and then it was mentioned international level, and it was also mentioned the US. But really the common sense level at which this first debate needs to take place, and at which some of these groups and the thinking is going on in other countries, should happen is at the European level. The second point is we've talked a lot about the risks, but really the report was about opportunities first. And the opportunities is not about just better sunscreen, with due reference to Baz Luhrmann. The future is not about the way the Horizon program on BBC painted nanotechnology, but the future is about embedded nanotechnology which enables biotechnology, information technology, and enables new things to be done in the cognitive sciences, which have hitherto been impossible or improbable. These will cause profound effects on the way we do everything, and these are the issues that really need to be taken up as soon as possible. And yes, we are ahead of the curve, Nick, but we're ahead of the curve in worrying about these things. The Americans are just going ahead and doing it. We do need regulation, but I was sobered. I was a couple of weeks ago at the Institute of Solar Nanotechnology. They showed me the lab, $10 million worth of equipment, but the computer was sitting on top of 3 boxes from Pizza Hut. And I said, why is the computer on 3 boxes from Pizza Hut? And the student turned around and he said, we have $10 million worth of equipment in this laboratory, but I can only get leads that reach 6 foot long. So the lesson is we don't need to look at old things and try new technologies. For new technologies, we need new opportunities, new ethics, and new codes and new ways of doing things. And the sooner that debate starts, with all actors, NGOs, and incidentally church groups too. We had very good input from the church at our meeting last week, and at the largest possible European level, because European market is the largest market, and at the end it's about competitiveness, it's about the knowledge-based economy and the Lisbon agenda for everybody. Thank you.
Thank you very much indeed. And I think you've already got a microphone in the middle there, have you? Yes, yeah, you're holding it. Yeah.
Hello. Hi. I guess I'm just going to echo what's been said. I'm from the U.S., and I've been studying this for the past 3 months for the LSE, and we are concerned about it in the U.S., I have to admit. But there are a couple major initiatives in research in the U.S., and nanotechnology is one of the only ones that's had double-digit increases in the past 5 years. The other is that still increases, gets increases in funding is climate change. But to echo what Doug was saying, those two aren't linked. You know, the problem is not linked with what I would consider to be solutions. And I just wanted to mention that there's a nanotechnology preparedness center that's recommended in the December 2003 Research and Development Act that was passed in the U.S. That has moved more slowly than anything else. And I ask what it's about, and I hear, oh, it's going to facilitate commercialization of products that are in basic research, or it's going to look at this, address the societal and ethical implications. And it's very unclear what that will be. It's being headed up by the National Science Foundation, which is the same organization that's really directed the definitions of nanotechnologies for the past 5 years. So I guess I'm pointing to the same hole that Doug mentioned, which is that there isn't this leadership in identifying the good applications and capitalizing on those. And I think the biggest risk from this technology is not doing that.
Thank you very much indeed. Yes. Oh, I'm sorry. Who's going to...
We weren't sure which you
How can I possibly decide? As long as you're brief, I'm going to go to both of you.
Well, I just want to ask the question about whether it's really helpful, and I'm very open-minded about this, to be lumping all of these technologies together. Just because nanotechnology sounds so new and so frightening, and Doug was using words like, well, we want to be in favour of. How can you be in favour of nanotechnology or not in favour? You're talking about so many different things.
Of course, exactly the same has been said about GM as well.
Absolutely, absolutely. And we run very similar risks, I think. I think it's really worth us deconstructing the whole term and taking very seriously all of the recommendations and everything that's come out, but perhaps targeting things very, very carefully. And I think, Nick, you said, we're already breathing them in. I mean, we've been breathing them in ever since we've been making fire and before. So I think it's very easy for us to get scary and brandish many, many different areas of research with kind of one single brush.
Thank you very much indeed. And just behind you.
I'm Maggie G. I'm a novelist, not a scientist, so I can say I think everyone should read this report and that it's very well written. But I really
you
wanted
don't get higher praise than that.
I wanted to come back to what Ian Pearson said at the very beginning about the annex on self-replication and the so-called grey goo thing. It is a splendid report, but in that the annex is a very small and late bit on this subject, and in that self-replication is linked to grey goo, perhaps the possible importance of self-replication has been diminished. And I noticed that a quote from Eric Drexler is used to support dropping, not taking self-replication too seriously at the moment. Well, I think Eric Drexler has been an apostle of nanotechnology for about 20 years, and I'm pretty sure that a novel I wrote 8 years ago based on self-replication was based upon Eric Drexler's thoughts on the possibilities of self-replication. So I just wonder whether self-replication would clearly make all the dangers of pollution much greater. And I just thought, very good that you included it, but it would be nice if that didn't get onto the back burner too much.
Yeah.
Thank you.
Okay. Very quickly, and do you want to respond to that?
I really would like to see more emphasis on that sort of stuff. I think it's a small risk today. In the long term, it's potentially a bigger risk. We don't know the answers to it, and I think we need to do more research with that, with a more open mind. The reason I'm concerned about it is because, since I joined my company, the number of times I've suggested doing something, and our best scientists have said you can't do that because it contradicts the laws of physics, and within 3 years it's become industry standard practice. I have lost count of the number of times that's happened, and when I see eminent scientists saying something is impossible, I have a high degree of skepticism. I think, well, you can't do it this way. Maybe you can't make little stainless steel robots, but supposing like a virus hijacks the reproductive mechanisms within ordinary cells, cell to reproduce itself, are there not sort of devious ways in which you can do this? And I think we need to be a little bit more careful before we dismiss things.
Okay.
That's all. I don't lose any sleep over this issue. I think we've got some time to worry about it, and as long as we do more research, I'll be quite happy.
I'm going to have to move on. George, I know you're so sorry. But look, what I'm going to do, the one person in this room, this is all going to tip into the lap of more than anybody else, and perhaps more than anybody else in the country, is David King. David, what's your reaction to what you've heard? And you're going to tell us what you're going to do about it?
No, I'm not actually going to do that, but I thought I also ought to first of all stand up and say that it was the government that commissioned the Royal Society and the Royal Academy of Engineering to carry out this report. There was a little fact that got lost on the way. And the reason why we commissioned this is because we do feel that we've learned that it's necessary with major technological developments to ensure that the debate takes place upstream. Precisely the point that has been developed. And I want to say it's a very useful report. It forms the basis, it has formed tonight the basis for an excellent discussion and debate. It will form the basis for further dialogue and debate within government, and a group of departments, the Department of Trade and Industry, the Department for the Environment, Food and Rural Affairs, the Department of Health, are already working together with the Health and Safety Executive and the Environment Agency on a number of issues raised in the report. So just to say, yes, we are already taking it up and pursuing it. The report is helping us to focus on the crucial areas that we need to coordinate in terms of research as well. So these are things that we're picking up on. You asked me, am I going to respond? The government will respond to the report by the end of the year after it has reflected carefully on all of the recommendations and all of the discussion and the debate. But what I would like to do is to particularly thank Nick Ross for his excellent chairmanship and stewardship of this evening's discussion. Nick, as always, you seem to do a wonderful job on that. I want to thank the Royal Society for arranging the meeting. But of course, in particular, thanks to the Royal Society and the Royal Academy of Engineering for all the work that they've put into this nanoscience and nanotechnology report. Many thanks.
David, thank you very, very much indeed. We on the panel have been tasked to make sure we finish by 7:45, but by 7:55 at the absolute latest, we're going to scrape in by a few seconds. Look, all it remains for me to do is to thank the panel very much, to thank the government who, after all, did commission this, to thank the Royal Academy of Engineers and the Royal Society. My God, if all audiences are as articulate, as thoughtful, and as smart as we've got here, I can tell the producers for Panorama and Question Time not to go anywhere else but the Royal Society to recruit their members. I just, for me, want to thank you very, very much indeed for coming. And I'm going to hand over to Philip Ruffles, the Vice President of the Royal Academy of Engineers, who sort of co-authored the report.
Good evening, ladies and gentlemen. It's my great pleasure on behalf of both the Royal Society and the Royal Academy of Engineering to give the final vote of thanks. I think in so doing, I firstly have to thank the working group themselves for producing, I think, an excellent report. It has breadth, it has focus in focusing on the right issues, and it has balance. And I think to get all three of those right at the same point in time, I think is credit to all the people who contributed. Because without the report, we couldn't have had such a constructive discussion this evening. I think tonight's discussion has illustrated very well, I think, a level of maturity, which I think, encouraged by the report, which I think has been extremely valuable to everybody present. And I'd like to thank, firstly, the panel, and also those people, in particular those people from the audience that contributed to that discussion. Finally, I think I'd like to thank particularly Nick Ross for his very effective chairmanship. I think without that it would not have been such a good and fruitful occasion. So thank you very much, Nick. And finally, in case they get forgotten, thanks to all the supporting staff of the Royal Society and the Royal Academy of Engineering who've made both the report possible and this evening. Thank you very much indeed.